Hello, hello students.
Okay, that's fine. So you rather put the headphones.
Can you unrecord now?
Okay, also it's okay.
So dear students, I am going to answer the first question. Let me read out the question once more. In successive measurements of period of oscillation of a simple pendulum, the readings are 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds. The questions are, we need to calculate absolute error, relative error and percentage error. Now to find absolute error, relative error and percentage error, the first and foremost thing is that we need to find the true value of these, measurements. So how to find the true value? The way to find true value is something like this. I am writing here true value. True value is going to be, sum of all these 5 values, whatever we got in the as given in the question, and it has to be divided by the number of measurement that is fine. So it has to be 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by how many experiments are there. If you see, there are 1, 2, 3, 4 and 5. So it should be divided by 5. That is the true value. Now if you find this true value, you will get this thing is equal to, if you add all the values, all the 5 values in the numerator, you will get it is 13.12. So it is 13.12 divided by 5. Now 13.12 divided by 5, this gives you a result is 2.624 second. Now this 2.624 seconds has to be rounded up to 2 decimal places. The reason is that as all the given numbers are given in the 2 decimal places. So the exact explanation for this is that whatever the numbers are given, out of those numbers, what is having the least decimal places, that number we need to provide in the result. So as we see, in the given number, the least decimal places is 2. So then the number 2.624 second has to be reduced to 2 decimal places. And if you reduce that number 2.624 to 2 decimal places, it becomes 2.62 second. Correct? And obviously,
Yes, sir.
okay, got it?
Yes, sir.
Okay, great. Obviously, this is, in second, and this is also in second, and this thing. So this is the true value. Next one is coming is that how to find the absolute error. Now to find that absolute error, what we need to do is that we need to find that each individual error and find their absolute value, that means positive value, and those errors should be added and divided by the number of measurement, that is a 5. So if I write that absolute error, it is something like that. Absolute error is something like this. So as I say, that you need to find that ET division error, that is mod of 2.62 minus 2.63. That is the first error, isn't it? Because 2.62 is the
Yes, sir.
2.62 is that 2.62 is the true value. Now in the first experiment, error is 2.62 minus 2.63. Then that is the first error. Then it is coming the second one. Second one is coming something like this. Is that mod of 2.62 minus 2.56.
Yes, sir.
2.56 plus.
Yes, sir.
Then it is coming 2.62.
2.62
Yeah. Minus
minus 2.71.
2.42.
2.42. Yes, sir.
Yeah. So 2.42. Correct.
Yes, sir.
Then the next one will be 2.71. Correct.
Yes, yes, sir.
Okay. The next one will be mod 2.62 minus
Minus 2.80.
uh,
Side this.
okay. So if you see here, so 2.62 minus
2.80.
2.71. 2.71 we have not done, na?
Yes, sir.
Plus 2.62 minus 2.
Minus 2.80.
Correct. And that has to be divided by 5.
5.
And if you
Okay,
calculate all these things
okay,
into
sir.
another value, you will get a value something like, let me write one by one all these values. The first
Yes,
one
sir.
is coming 0.01.
Yes, sir.
Second one is coming 0.06.
0. Yes, sir.
Third one is coming 0.20.
0.10.
Are you sure? 0.20.
Oh, yeah.
Then
Yes, sir.
it
Sir,
is
first one is minus 0.10, no, sir.
correct, but it is a mod value. Mod value means it is a
First one.
positive value. Correct.
Okay, sir.
Because positive value.
Okay, sir.
So we'll take the non-negative value, and then the last one is 0.18. And that has to be divided by 5.
Yes, sir.
If you calculate this value is
Yes, sir.
0.108. But your
Yes, sir.
your result has to be expressed in 2 decimal places, because all the values have been given in 2 decimal places. So if you express this 0.108 into 2 decimal places, 8 is more than 5, so it will be 0.11. That is the absolute error.
0. Yes, sir.
Now,
Okay, sir.
after that, what is coming? What is coming is that After absolute error, it is a relative error. And what is relative error? Relative error is something like this thing. Relative error is equal to absolute error by true value. So I am writing here relative error what is the absolute error? 0.11 divided by the true value is 2.62, and if you divide you will get the value 0.04. That is the
Network.
nothing can be done now. Shall I pause? Got it? Okay.
Yes, sir.
That substance is so how to find the dimensional analysis of the bulk modulus?
Sir.
Yeah.
Yes, sir.
Yeah. Just give me a minute. Uh,
Okay.
okay. Now, so to find the dimensional analysis of the bulk modulus, the way we can find is that, so there is another formula I have written here. If you look into it, is that bulk modulus is equal to B is equal to minus V into dPdV. Means you are putting the pressure, but based on that, by pressing the pressure, how that volume is actually getting changed. Okay, so minus V into
Okay.
dV, that is called the bulk modulus. Now, V and dV both has the same dimension L. That's what it get cancelled out. And
Cancelled. Yes, sir.
so we know what is the dimension of pressure. Dimension of pressure is that force per area. Okay.
Yes, sir.
Yes, sir.
Yes,
What is force? Force is that m L T to the power minus 2 by L square.
plus minus 2.
Correct.
Yes, sir.
And so that
Yes, sir.
L T to the power minus 2 by L square is actually become m L power minus 1 into T power minus 2, that is the pressure. So now that become
Sir, ML minus 1, no, sir.
m L power minus 1, correct, exactly.
L minus 1.
L minus
Yes,
1,
sir.
minus 1 actually. Okay, so this what
Yes, sir.
you see, this is actually minus 1.
Okay, sir.
Okay, just give me a minute.
Okay.
Let me erase and then let me show you.
Okay.
Okay, so let me write it here. Okay.
Okay, sir.
So let me show you how we can find that this thing, that dimensional formula for that bulk modulus.
Modulus.
Yeah, bulk modulus.
Sir, what is the unit for bulk modulus, sir?
Huh?
Unit of bulk modulus.
So unit of bulk modulus you can define now.
Yes, sir. After seeing that dimensional analysis.
Correct, exactly.
Yes, sir. After seeing the dimensional.
Dimensional analysis, right? So
Okay.
now, so as we see that
Yes, sir.
for the bulk
Yes, sir.
modulus, it is the same as the inverse of the pressure, right? So what we can write it is, so from here you see, so now let me Okay, so then what we get? We get in the left hand side m power 0, L power 0,
L power 0,
t power minus 1
T1 minus 1.
is equal to
Yes, sir.
k into, if you see in the m power a and m power c, so it is m power a plus c. Hello, got it or not?
Yes, sir. Got it, sir.
Yes, sir.
M plus a, m power a plus c. Then L power, can you please tell me what will be L power?
B.
No,
B
b minus c.
minus 1.
B plus C.
B minus c.
Okay, sir.
Why okay?
Yes, sir. Yes,
L
sir.
power minus
Yes,
1 plus
got it, sir.
L power
Yes, sir.
minus c.
Yes, sir. Yes, sir. Yes, sir.
And what will be t?
T power minus 2C.
Minus 2C.
Correct?
Yes, sir. Minus 2C.
Yes, sir.
Okay, just a minute. So what I'm saying is that, just a minute. Okay. So what I'm saying, so just a minute. So let me explain a little bit from the beginning. So we found that bulk modulus is here. This thing. Just a minute. So as it is going to be m power m power minus 1, L power 1 and t power 2 power c, because 1 by pressure, no? So then on the left hand side, what is coming? In the left hand side, it is coming something like this: m power 0, L power 0, t power minus 1 is equal to k into, if you see m power, it will become a minus c,
A minus 1.
a minus c,
Yes, sir.
because minus 1 power c, na? Then it will be L power b plus c,
Yes, sir. Yes, sir.
and it will be t power 2c. You
Yes,
agree?
sir. Yes, sir.
So now we can equate both the sides. In the left hand side, what we see, that m power 0, and the right hand side it is m power a minus c. So what we can say, a minus c is equal to 0.
Yes, sir.
Then we can say that L power 0 in the left hand
A is
side,
equal
right
to
hand side
C.
is equal to
A is
b
equal
plus
to
c.
C.
B plus c is equal to 0.
Yes, sir.
And in the left hand side is t power
Yes,
minus
sir.
1, and in the right hand side t power 2c. So we can say that 2c is equal to
Minus
minus 1.
1.
Equal
Yes.
to. Yes, sir.
Correct. So from there, what we can say?
A is equal to C.
Very good. We can say that A is equal to C, B is
B
equal
equals
to
minus C.
minus C, and C is equal to minus
Minus 1
1
by
by
2.
2. Now, as C is equal to minus 1 by 2, we get
We can
A is equal
substitute
to,
the value of
yeah,
C.
correct. We get A is equal to minus 1 by 2,
Yes, sir.
B is
B
equal
is
to,
equal to
B
1
is
by
equal
2.
to 1 by 2.
and C is equal to
Minus 1 by 2.
minus 1.
Minus 1 by 2. That remains.
Now, what happened is that, if you see, very interesting thing. If you look into this,
Yes, sir.
here we wrote what? Here, if you look into this one, let me use a different color. Uh, Let me use a different color. Let me explain you. If you look into this one, that f is equal to k into m power a d power b into beta power c.
Beta
So
power C.
I am writing it here now. Okay. If I write it here, then what we'll get? We'll get the same thing here. That f, correct? F is equal to k into m
Yes.
power what? M power a. A is minus half.
Minus 1 by
Minus
2.
1 by 2.
Minus 1 by 2.
Yes, sir.
D power b, the d power is equal to 1 by 2,
1 by 2.
and
1 by 2.
beta power minus 1 by 2.
Minus 1 by 2.
Minus 1 by 2.
So from here what you can say? We can say f is equal to k into square root of d by m into beta.
Yes, sir.
Do you agree to me?
Yes, sir.
Because square root of d and
And
m and beta are power minus 2, na? Minus 1 by 2. So it comes in the denominator.
Yes, sir.
So that is the okay. That was the question.
Sir, can you explain the last step once again, sir?
Last step is that m power minus 1 by 2 means 1 by m power 2. M power minus 1 by 2 means what? 1 by square root of m, na?
Yes, sir.
yes, sir. Yes, sir.
Beta power minus 1 by 2 minus 1 by square root of beta. So that m and beta become 1 by square root. Correct?
Yes, sir.
Yes, sir.
Okay, great. Let's move to the third question. Third question is that the time period t, the vibration of a liquid drop depends on the surface tension A, the radius r of the drop, and density rho of the liquid. Find the value of t. Correct?
Yes, sir.
Okay, great. Now, so what is that? The time period t is according to the question. What we get then? According to the question, we get this thing. We get the time period. Suppose time period we defined as t. It is varying to surface tension.
Surface tension, radius, and also rho.
So it is varying to that radius r, so r power b,
B.
and it is varying to the density, that is
Density. Rho power C.
rho power c. Now if we club together, then what we can write?
S power A.
T is proportional to exactly
S power A, R power B, and rho power C.
correct, r power b and rho power c. Now what we can say from here, from the proportionality constant, if we introduce a proportionality constant, we can say t is equal to
T is equal to
T is
K,
equal to K, S
S
power A,
power
R
A,
power
R
B,
power B, and rho power C.
rho power c.
rho
Correct.
power C.
Right. Now what is the dimensional analysis of t? Is dimensional
T.
analysis of t is that we all know it is m power 0,
M power
power
0,
power
L
0,
power 0, T power
L
1.
power 0,
k is dimension. Now we need to say what is surface tension. So surface tension, let me explain you here. What is surface tension? So surface tension is something that all will come when we discuss about the mechanical properties of solid,
Force by length.
all these things, is the force by length. So that is equal to force by
length.
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 Correct? Okay.
Exactly.
Force by length,
Yes, sir.
and always
Yes, sir.
you remember what is the dimensional analysis of force? Dimensional analysis of force.
M power 1 M power 1, L power 1, and T power minus 2.
Fantastic. And if you divide it by length, then L power becomes 0, isn't it?
Yes.
Because
Yes, sir.
as you very correctly said, force is equal to mass into
M power 1.
ml
Yes.
power minus 2 divided by length is
Yes,
Divided
sir.
by length.
so it becomes what?
M power 0, L power 0, T power
and T power minus 2.
minus 2.
Yes, sir.
All of you agree to me?
Yes, sir.
Yes, sir.
Great. That means in case of surface tension, we can write this thing very clearly. What you can write? M power 1
M power 1, L power 0,
L
T
power
power
0
minus
T
2.
power minus 2. Yes, sir.
to power A. And what is R? Can you tell me what is the dimensional analysis of R?
L power 1 by 2.
What is R?
No, L power.
R is radius. Radius is always length.
Yes, sir.
Correct? And what is
Sir,
rho?
for that,
L power B.
Rho is density.
Correct? Isn't it?
yes, sir.
And
Yes, sir.
what is rho? What is the dimensional analysis of rho? The density.
M power 1, L power minus 3, and T power 0.
Fantastic. L power 1. All of you understood? L power 1. Sorry, I'm sorry. M power 1.
M power 1.
Yeah. M power 1 and
L power
L
minus
power
3.
minus
power
3.
minus 3 means what? Volume, na? Power C.
Yes, sir.
Yes, sir. Volume.
Yes, sir.
Yes, sir. T power minus 0.
Now, if you compute all these things, what we'll get? We'll get
T
Yes, sir.
power 1.
m power 0, l power 0, t power 1 is equal to k into
Yes, sir. Yes, sir.
m power. We'll get a plus c, isn't it?
Yes, sir.
Yes, sir.
L power
M power A plus C.
L power
L power
Only
B.
C, sir.
B minus 3C.
b minus
Sequence B. Yes, sir. B minus 3C.
exactly, and t power
Minus 2A.
minus 2a. Very good. So from
Yes,
here,
sir.
if we equate, what we'll get? We'll get a plus c equal to 0
A plus C is equal to 0. B minus
B
3C is
minus
equal to
3C
0.
equals 0.
and minus 2a is equal to
Minus 2A is equal to 1.
1.
1.
So
1.
this gives c is equal to minus a,
A. Yes.
correct?
Yes, sir.
B equals 3C.
Minus 3c is equal to, sorry,
No, sir. 3C.
correct. C is equal to 3c and
Yes, sir.
is equal to minus 1 by 2.
A is equal to minus 1 by 2.
So now let's apply these values. So what do you get?
Yes,
C
sir.
is equal to 1 by 2,
1 by 2
b is equal to 3 by
is
2,
equal to 3 by 2.
and a is equal
A
to
is equal to minus 1 by 2.
minus 1 by 2. Now apply all these values in this equation. Apply all these values similar to the sorry. Apply all
Yes,
Yes, sir. Yes, sir.
correct. If we apply all these
Yes, sir.
values in
Yes.
that equation,
Yes, sir.
what we'll get? You will get something like this. You will get t is equal to k into s. S is what?
S power
S power
Minus 1 by 2.
very good. That means
Yes, sir.
S power minus 1 by 2.
correct. S power minus 1 by 2.
1 by 2.
Then r power 3 by 2
3 by 2.
and
Rho power 1 by 2.
rho power 1 by 2. Correct. And that should imply t is equal to
T
k
is equal
into,
to
if you do all these things in a square root manner, it will be rho into r cube.
R
R cube. Yes,
cube.
divided by S.
Correct.
Yes, sir. Yes, sir.
Correct.
Yes, sir.
Fine. Any other question?
Yes, sir.
Okay.
Yes, sir.
Now let's go to the fourth question.
Fourth question.
Correct. Using dimensional analysis, test the correctness of the following equations. Okay. dimensional analysis test the correctness of the following equation. So let's first the first one is that H is equal to 2s cos theta by rho rg. Okay. Hello? Got it?
Yes,
sir.
sir.
So what is the first equation? The part A. The part A equation is that H is equal to 2 into
2s cos theta by rho
by
g.
rho into R into G.
R into G.
So now let's give this equation as equation number 1.
1.
Yes, sir.
What is the dimension of it in the left hand side?
H, sir.
L power 1.
Huh?
L to the power 1.
Correct. Exactly. In the above equation 1, if I write in the above equation 1, LHS is H.
Sir, what is H, sir?
H is the height. It is actually defined. It actually defines that how much height a liquid can go in a capillary tube. That you will understand later.
Oh, yes, sir.
Okay. This
Oh, okay.
Newton's law, which describes the rise and fall of a liquid within a thin capillary tube. Okay, if H is the distance, traversed by a liquid in the capillary tube, that is called the H. Okay,
Okay,
Yes.
sir.
and this is H, and what we can say, sorry, H, and we can say that having dimension
L power M power 0, L power 1,
having dimension,
T power 0.
correct, having dimension L,
M power 0.
yeah,
Yes, sir. Yes, sir. Okay, sir.
M power 0, L power 1,
L power
L power
1,
1,
T power 0.
T
T
power.
power 0.
T power 0.
Okay, in the right hand side also we should have the same thing. Okay,
Yes,
Yes,
sir.
sir.
in the right hand side. In the right hand side, what is the first one? The S is the surface tension. So let me write.
Okay.
Is surface tension. This is surface tension. Okay.
Yes.
Tension.
Yes, sir.
Surface tension. Let me write it down. Surface tension is the elastic tendency.
Force. Yes, sir.
Elastic tendency is the elastic tendency of a fluid.
Okay.
Of a fluid surface, which makes it acquire, the least surface area.
Yes, sir.
Least surface area. Least surface area possible. Okay, and is equal to. So what is S? S is surface tension, and it is the
Yes, sir.
tendency of a fluid surface which makes it acquire the least surface area possible. Okay, and is equal to force by correct,
Yes, yes. Yes, sir.
and is equal to
Force by length.
Yes.
force by length.
Yes, sir.
What is the dimension of force? Force is mass, so S is having dimension.
Yes, sir.
So
M power 1,
M
L
power 1,
T power minus 1.
exactly. So S is having dimension
M power 1,
M power 1,
L
L
power
power
0,
0,
T
T
power
power minus 2.
minus 2.
yes M
T
L
power minus 2.
M power 0
T power minus
M,
1.
T
sir,
power
M power
minus
1.
M power 0 L
M power 1, L power 0.
M power 1, L power 0.
Yes,
sorry.
sir.
Yes, sir.
So it is having this thing that T power 1 L power 1 T
L power 0, sir.
minus 2 I'm coming by L. Nah?
Okay. L.
So that is what we can say is that is nothing but
LL cancels.
LL cancelled M into M L power 0 T power minus 2.
Yes, sir.
So what we
Yes.
get is M L power 0 power,
T power minus 2.
correct?
Yes, sir.
So this is the surface tensor. Now what is the dimension of cos theta?
Cos theta.
It's dimensionless, it's a constant.
Huh?
It's dimensionless.
Yes, exactly. Very good. Very good.
Theta value don't. Yes, sir.
No, theta, no, not theta. Theta, is dimensionless, but
It is a constant.
but it doesn't. It has a unit, but trigonometric ratio neither has unit nor has dimension. So what we can do is
Yes, sir.
sorry. So here I am going to write is that trigonometric ratios are dimensionless.
Yes, sir.
Trigonometric ratios dimensionless. Hence, cos theta is having no dimension. Cos theta has no
No
Has no
dimension.
dimension.
fine. Then what is the next one? Is rho. Okay. So 2s cos theta. Next one is coming rho. Okay. So density is the mass per unit volume.
Yes, sir.
Correct? Isn't it?
Yes.
ML power minus 3.
M L power minus 3. Correct.
Minus 3.
Exactly. So we can write it here. Density is the mass per unit volume. Density is the mass per unit volume.
Sir, rope is density, sir.
Yeah, rho is density, correct. It is given in the question also. Read out that it is rho is density. Density is the mass per unit.
Okay, sir. Okay.
Hence, rho is having dimension. Rho is having
M power 1, L power minus 3, T power 0.
correct. Very good. Rho is having M power 1, L power minus 3, T power 0. Correct. So now R is having
Yes, sir.
dimension what? R is having dimension. Can you tell me what is the dimension of R? It is L.
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 Correct?
Yes, sir. Radius L.
Correct.
Yes, sir.
Next one is coming G.
Acceleration.
LT power minus 2.
Yes, LT power minus 2.
Very good. Who said?
So this is Akanksha.
Wow, Akanksha, very nice to hear you after a long time. How are you?
Same here. I'm fine, sir. How are you?
Good, very good. Thank you. Thanks for attending this session. Okay, because we are using some latest technology and because of that there are some kind you all get
From
few classes. But how you are liking means you are able to see everything very clearly.
Yes, yes.
Okay, great. So it will get improved in another few days. It will get improved. So anyway, let's come back to the discussion. R is having dimension L. Then next one is G. What is the dimension of G?
N power 0, L power 1, and T power minus
T
2.
power minus 2.
How come? Because G is nothing but acceleration.
Acceleration.
Velocity by time.
Acceleration. G is acceleration due to gravity.
Yes.
Yes, sir.
So obviously,
Acceleration due to gravity. Yes, sir.
so it will have the same dimension as acceleration. Okay.
Yes, sir.
Yes, sir.
Right, and is having dimensions same as acceleration, same as
Yes, sir.
acceleration. That is,
Yes, sir.
we can write m power 0, L
L
power
2
1,
minus
T power
M power 0, L power 1
minus 2.
minus 2.
Now,
Yes, sir.
so we get all the dimensions of individual, terms in the right hand side. So the
Yes,
dimension
sir.
in the right hand side of the above equation 1. So this is the equation 1 now. This is the above equation.
Yes, sir.
So we get 2a cos
Yes, sir.
power g. What is the dimension of 2?
No dimension.
No dimension. It's only 2 constant.
Fantastic. Great.
Constant.
Exactly. So what we can write here is that dimension in the right hand side. So the dimension in the right hand side of the above equation 1 is first one is that what? First one is
M1 T power minus
yes,
2.
yes. What is this?
By
We already found it out. Yes, we already m L power 0 T power minus 2, isn't it?
Yes, sir.
So
Yeah.
what we get? M L power 0 T power minus 2
minus 2.
divided by
M power 1 L
m
power
L
minus
power
3
minus 3
into L power minus 1 into L power 1.
into L power 1 into m power 0
L power 2
Yeah.
minus 2.
power 1 T power minus 2.
Minus
Minus 2.
Correct.
So this becomes, in the numerator we get L power 0, because if you see that m and m got cancelled,
Cancel. T power minus 2 and T power minus 2
power
also
minus
got
2
cancelled.
so we'll get numerator L power 0 and denominator we get L power minus 1.
Yes, sir.
So we get L, but in the left hand side also we got L, na?
Yes, sir.
Left hand side is H, it is L, right hand side also L, okay?
Yes, sir.
So hence it is dimensionally correct. So what we can write? We can write something like that. See, as we see the dimensions
Both left hand side and right hand side are the same.
of
same dimensions.
correct, exactly, both LHS and RHS of the above equation 1 is is same, hence it is dimensionally correct. Hence it is
Yes, sir. Understood, sir.
okay. Dimensionally correct. Okay. Now the point is, so what this this formula mean for. So let me also write it down. So by the way, the equation H is equal to 2a
2s cos theta by rho RG.
by rho into R into G is the formula Jurin's law. That is something called Jurin's RINS, Jurin's law. Okay, which
Yes, sir.
describes the rise and fall of a liquid,
Of height.
within a thin capillary tube. A thin capillary tube. Okay, correct?
Yes, sir.
So let's now come to the next question. Oh, okay.
This question.
Okay, this
Sir, we
question.
did not do the volume, sir.
Huh? Yeah, correct. Exactly.
Volume.
Exactly. So, can you tell me whether the second one is dimensionally correct or not? You work out and let me
Yes,
know.
sir.
You can take some
Yes, sir.
5
Sure.
minutes and tell whether it is dimensionally correct or not. All of you, can you
Yes, sir.
try?
No only, sir.
Yep, absolutely.
Excuse me, sir.
बताओ ना. Sir, question is not visible.
Huh? Yeah. No,
Yes, sir.
question. Yeah, fine. You write it down.
Sir, can you please tell the formula for coefficient of viscosity?
Yeah, very good question. That I will definitely tell you. Yeah. The question is very relevant. So I will explain you what is coefficient of viscosity. So coefficient of viscosity is nothing but force into distance by area into velocity. That is called coefficient of viscosity. Coefficient of viscosity is equal to force into distance by area into velocity. I will explain you, but as I am defining you, with this you can proceed, isn't it?
Yes,
Yes,
sir.
sir.
Because you know the dimension of force, you know the dimension of distance, you know the dimension of area, and you know the dimension of velocity.
Yes, sir.
Correct. Proceed.
Sir, can you please repeat what is coefficient of viscosity, sir?
Yeah, the coefficient of viscosity is equal to force into distance by area into velocity.
Thank you, sir.
Okay. So I'm writing in the here is the equation. So V is equal to I
Pi.
into R power 4 into T by 8 into eta into L. Suppose this you give the equation number 1. Correct?
Yes, sir. V is equal to L cube.
Yeah, sorry.
V is
Correct.
equal to L cube.
V equal to L cube. Very good. Very
L
good.
cube. Yes, sir. Yes, sir. V is equal to L cube.
Correct. Okay.
Yes, sir.
So you can write equation 1 LH
LH is volume.
and having dimension.
L cube.
Correct. Okay. What is the dimension of pi?
Constant, sir. It doesn't have.
No dimension.
No dimension.
Yeah. So constant doesn't mean that it has to be, it may not have dimension. For example, gravitational constant has dimension.
Gravitational constant.
Yes, yes,
Okay.
yes.
So it may possible that constant have dimension. Okay. Again, it is possible that something, it neither have dimension nor has, unit. Pi is something
Yes, sir.
doesn't have unit but not have dimension. But
Yes,
whereas,
sir.
Yes.
angle is having a unit, right? Degree or radian,
Yes, sir.
but it doesn't have dimension. So
Yes, sir.
dimensionless. What is the dimension of P? Pressure?
M to the power 1, L to the power minus 2, T to the power minus 2.
No, wrong.
L power minus 1.
Correct. L power minus
Sir,
1.
it's L power minus 1.
M L power minus 1, T power minus 2.
Yes, sir.
Yeah.
2.
P is having dimension. P is having dimension M L power minus 1, T power
T power
minus 2.
minus 2.
Now, what is the dimension of R power 4?
L power 4.
Yeah, having
Yes, sir.
he is having dimension L power 4. Now, the dimension of T,
T itself.
T.
yeah, T is having dimension
T.
E.
Next one is coming the coefficient
Okay, sir.
of viscosity. That is a very important topic. Okay, because you do not know this thing as of now. You know what is coefficient
Yes,
of
sir.
viscosity? I am writing it down so that also you can. I will also read along. I am writing, and you will get the idea.
Sir, it is pressure by acceleration.
Huh?
Pressure by acceleration.
Are you sure?
Yes, sir.
Pressure. What is pressure? Pressure is equal to
Force by area.
correct. And what is acceleration?
Velocity by time.
Velocity by
Change in velocity by time.
correct. Velocity by time. It is not because as I said few minutes back that coefficient of
Force
viscosity.
It's
into
velocity by distance.
Force into displacement by area and velocity.
Correct. Exactly. Who is talking?
Okay.
Naga?
yes, sir.
Okay. Good. Anyway, so I'm writing it here. Eta is the coefficient of viscosity. I'm writing it out so that you can also go through it as we write. Huh?
Yes, sir.
Okay.
So eta is
Coefficient of
viscosity. Coefficient of viscosity is the
yes, sir.
degree to which degree to which a fluid resists flow under an applied force. Flow under applied measured by the. So how it is measured? By the measured by the tangential friction force. Measured by the tangential friction force or unit area divided by the velocity gradient divided by the velocity gradient sorry velocity gradient under conditions of streamline flow under
Sir, what is velocity gradient?
velocity gradient, very good question. That how velocity is changing with respect to distance. Okay, it's
Okay.
called velocity gradient.
Sir, what is
Yes.
tangential friction?
Huh?
What
Okay.
is tangential friction?
Tangential friction force which works on the surface. Okay, and along the tangent of that, surface one. All these things will be clear when you will discuss about the mechanical properties of fluids. Okay,
Okay, sir.
got it? Velocity gradient
Yes, sir.
Yes.
under conditions of streamline flow condition of streamline flow. Streamline flow. So what we can write is that, so we can write, so coefficient of viscosity is equal to force into distance divided by area into velocity. Correct?
Yes, sir.
So as we know that coefficient of viscosity is described by eta. So from here what we can write? We can write the dimension of eta is equal to force.
L power minus.
Yeah. So force is equal to what? Force is equal to
ml t power minus 2.
yeah, exactly. ml t power minus 2
Minus 2.
into distance is L, correct?
L.
And area is nothing but L square
L square.
into velocity is L t to the power minus 1.
Minus 1.
Yes, sir.
So now if you compute this thing, it will reduce to m L power minus 1 t power minus 1.
T power minus 1.
So what are the things we have found it out so far? We have found out that in the right hand side only one thing left is L. L is obviously length, na? L, correct?
Yes, sir.
L is the length of the pipe, by the way, in the in terms of that coefficient of viscosity. So L is having dimension. L is having dimension of L. Okay.
Hello, sir.
Yeah.
Hello.
Yeah, please. Hello, who is speaking? So the dimension in the right hand side, dimension in the side of the above equation equation 1.
Hello?
Yeah, hello, what happened?
Sir,
Yeah,
Girish.
yeah, fine. All right. Good evening, Girish. M L
Yes, sir.
power minus 1, T power minus 2, then L power 4. Correct? Am I writing correct?
Yes, sir.
Into
Yes,
C
sir.
divided by M,
L.
L power minus 1 and D power minus 1
correct, T power minus 1 into
and L.
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 So that is equal to L cube. So we
Yes,
see,
sir.
okay, what we see?
Hmm.
We see both left hand side and right hand side having the same dimension of L cube. So
Yes,
this is
sir.
also dimensionally correct.
Yes, sir.
Yes, sir.
So what you
Sir,
can
it
do?
also proves
sir.
Sorry?
the principle of homogeneity.
Exactly, correct. That's what it is true, na? Dimensionally correct.
Yeah. Okay, sir. Yes.
So you can write as well, na? As
Sir, what is homogeneity?
homogeneity means both left hand side and right hand side has the same dimension. As we see,
Yes, sir.
the dimensions of of both left hand side and right hand side.
Are the same.
Correct. Right hand side are same. Okay, are same. The equation is dimensionally correct.
Correct.
Correct? Okay?
Yes, sir.
Yes, sir.
So by the way, so for your more information, I'm going to write something, and please, take a note of it. This thing. So what it says
Yes,
is
sir.
that the equation v phi into r power 4 into t divided by 8 into eta into L is the formula based on,
Is the formula?
yeah, I'm writing based on Cauchy-Neely's law, based on POISE
Yes, sir.
yeah, Cauchy-Neely's law. So it states that it states that the flow of fluid
Fluid.
is related to a number of factors. Is related to a number of factors. What are the factors? Like
Pressure, radius, time.
viscosity of the fluid, the pressure gradient across the tubing, the pressure gradient across the tubing, the length and diameter of the tube, the length and diameter length and diameter of the tube, and time duration. Correct. All these things we'll discuss in details during the study of mechanical properties of fluids. So these
Sir?
two answers we have given. Now let's come to the fifth question. So the question is that the volume of an object is a function of time. The volume of an object as a function of time is calculated by V is equal to a power a into t power 3 plus b by t, where t is time measured in seconds and v is cubic meters. Determine the dimensions of the constant a and b. Okay.
Yes, sir.
As we know, that the dimensions of both left hand side and right hand side has to be equal.
Equal.
Yes, sir.
Correct or not?
Yes,
Yes,
sir.
sir.
Let me write the equation. So what is the equation? Equation is v is equal
V
to
is equal to
a into t power
8t
3
cube
plus
plus D by T.
plus
B by T.
b by t.
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 Now let's look into the volume V. What is its dimension?
L cube.
L cube.
Very good. Its dimension is L cube. So then this right hand side, this also has to be L cube. And
Yes, sir.
this also
Yes,
has
Yes,
to
sir.
be L cube. Then only it will add up, na?
L cube.
Yes,
So
sir.
that means,
Yes, sir.
so this has to be L cube. Correct?
Yes, sir.
How, sir?
This,
The sum should be L cube, no, sir.
otherwise it cannot
Yes,
have.
the sum should be the cube.
Correct.
No.
That means to become it is L cube, what we can conclude? It has to be that A into T cube, correct? Has to be L cube,
Yes, sir.
correct or
L
not?
cube.
Yes, sir. Yes,
So
sir.
from here we can find the dimension of A
Yes,
Yes,
sir.
sir.
Correct, sir.
L power 3, T power minus 3.
L cube t power minus 3.
Correct or not? And look at here.
Yes, sir.
Yes, sir.
Here it will be into T power minus 1. Girish, you
T power
understood?
minus
Yeah?
1.
Understood,
Yes,
sir.
sir.
Okay, so
Yeah.
this has
Understood.
to be L power 3. Correct or not?
Yes, sir.
Correct or not?
Yes, sir. Yes, sir.
Correct? So from here what we can say? We can say B is equal to L power 3 into T.
Yes.
Yes, sir.
Yes, sir.
So this is the dimension of the constant
B.
A and B. So here you note that
B.
A and B are constant, but they have dimensions, right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
What I'll do is that I would like to, put the session here because there are 15 objective questions. So we will communicate with some other day where we can discuss about this, this 15 MCQ questions. So
Yes.
Okay, sir.
you will get a communication from us soon, maybe by tomorrow or day after tomorrow. But meanwhile,
Yes, sir.
please listen to me first. Meanwhile, what you can do is that you solve those 15 questions and be ready with your answer so that in the next class when we will discuss, you will also make sure whatever you have done is correct or you need scope of improvement. You got my question?
Yes,
Sir,
sir.
how will we get this question, sir?
So already it is there. I shared that link. Na? In that link, it is there. Questions are there. Please check that WhatsApp message clearly before asking a question. Please, Ranjana.
Okay, sir.
Okay.
Okay, sir.
Okay. Thank you very much.
Excuse me, sir.
Hello.
Thank you, sir.
Yeah.
Sir, tomorrow class will be there, sir.
Huh?
Tomorrow our class will be there.
So that we'll discuss later. Okay.
Yes. Okay, sir. Okay.